Okay, so again, good morning, everyone. Great to see so many of you here today, new faces, familiar faces from previous conferences. Today I'm going to talk about one of my most favorite topics, security, and I'm sure it's your favorite topic too. So my name is Don Pinto. I'm one of the senior product managers at Couchbase, responsible for security, and I'm here with Rhythm.
I'm the senior manager with the QE organization here.
Okay, cool. So we're going to talk a little bit also a bit of futuristic stuff today. So here is a quick disclaimer around that towards the end of the talk, it's more given that it's futuristic, things may change because it's just a plan. And so let's get started. So security is on top of the minds for most of the deployments of any infrastructure product. And if you look at the 2016 Ponyman report, so this is pretty recent, you'll see that there are three main, I would say, the report reports three main causes of these kind of security breaches that occur. The most, as you can see, the pie chart says that the most common one is due to malicious or criminal attack. The more interesting part about it is it's hackers and criminals which are more insiders within organizations causing these attacks. There's also other causes of security breaches, human errors, misconfigurations, system glitches, and those also share quite a bit of percentage within this pie. The other aspect of this is the cost. As you can see that the cost of a malicious insider breach is way more expensive than the other kind of breaches. At least that's per record. And when a breach of that kind of nature occurs, many times more than one record is leaked out. So what am I going to talk about today, right? So we're going to talk about some of the things that you got to think about when you deploy Couchbase as your infrastructure of choice from a security perspective. What things that you may want to consider outside the Couchbase server, things you might want to consider within the Couchbase server. As I said, we'll go into a little bit of the security roadmap of things what's coming up, and then also do a quick demo. We'll also have a Q&A session at the end, so I know we have a good 50 minutes to deliver this session, so it'll be good if we can try to capture a lot of those questions towards the end of the talk. So let's get started with defense in depth. So I think everybody's familiar with this topic, right? So defense in depth, the way we define it is security at each layer. You have multiple layers in your stack, so you have security at each layer of the stack. You have security between layers. As layers interact with each other, you have security controls within these layers. And then also security between systems. As you deploy systems holistically, database systems, non-database systems within your infrastructure, you got to have security between these systems. And another aspect or way of looking at this is through a typical deployment architecture diagram of Couchbase. So what you can see here is how Couchbase is deployed typically. So you see Couchbase is mostly deployed in an internal network. You see it's a firewall infrastructure which is behind two levels of firewall, sometimes more. So users connect, and these are application users, so they connect to Couchbase through a web app which resides on a web server, which is served through a web server, and then the business logic managed in the application server, and then finally the data, which is the most important security piece that needs to be protected, resides in the database. So we're going to talk in the next few slides about each of these aspects and things that you can do at each of these levels. So let's start with bottoms up, looking at where most of the critical aspects reside, which is in the database. So we'll talk about in the database first. So Couchbase has made some significant investments over the last few releases. So what this slide shows you is the different areas that we have made these investments: authentication, authorization, crypto, auditing, operations. So these are what this slide shows you is the different features or controls that we have delivered in each of these different areas. Now, I'm not going to go over every single of these controls today, but what I'm going to touch upon is some of the most recent and exciting controls that we added in version 4.5 of the product. So the first one we'll talk about today is role-based access control for administrators. So first of all, what is role-based access control for administrators? So role-based access control allows you to map each administrator into a role and control access of what that administrator can do in the Couchbase system through role membership. So that's pretty much what role-based access control is. Some of the benefits of this features, the obvious ones, right? Regulatory compliance, that's an area where, which kind of requires unique identities for administrators, as well as the ability to control what each administrator can do within the system. That kind of brings us to the second benefit, which is segregation of duties. You don't want your admin to have everything or all the powers within the Couchbase cluster. You really want to break up the admin role, which is a powerful role, into a bunch of unique, distinct roles that are then you can give out to your individual admins. And finally, the third thing is security privilege separation. So what we mean by that is the ability for only a certain high privileged admins to have this security privilege, the ability to manage security within the system. Not every admin needs to be able to manage security. There's a designated set of admins who got to have the privilege to manage security, and that gives you the separation of security privileges. So how does it work? So I describe on the left on the slide how does it work, but we'll look at it through a picture. So you can imagine the world before RBAC or role-based access control in Couchbase. We had this concept called the full administrator. And again, as I described, the full administrator has the complete powers over the Couchbase cluster. And RBAC gives you a couple of benefits. The first one is cluster, the role what we added called cluster admin. And the difference between cluster admin and the full admin is giving you that security separation that we talked about. That cluster admins cannot do the security aspects that the full admin can do. So the full admin can do cluster admin as well as the security aspects. Then going deeper, we have the role called the bucket admin, and the bucket admin can control bucket settings. We have the ability, we'll later on see in the demo, that we have the ability to have this setting across buckets, through a wildcard, or we can go and have a bucket admin for a unique particular bucket. So depending on how you want to set up your admins, you have the flexibility when you're doing bucket administrator to configure it in that manner. Similarly, we have the view administrator. So this is a role for defining views and gives you the ability to define views through this role. And again, it is very specific to the view to views in Couchbase. And finally, we have XDCR admin. So again, as you know, XDCR gives you cross data center replication across two clusters in two different geographies. And maybe in your organizations you need a role which you want to give to an administrator whose responsibility is to just set up XDCR. And so that's kind of the role that you will give such an administrator. The next control we'll kind of talk about is X509 certificates for client-server TLS. So first of all, what is X509? I'm sure everyone is familiar with this acronym, but it's basically a standard, a public key cryptography standard to manage digital certificates whenever you have a client and a server. So it is a standard that is pretty common. Modern web browsers support X509 and just like any other clients. And some of the benefits that you get with X509, the first one being regulatory compliance, as you guys are all aware. Then there is trusted encryption, which means that between the client and the server, you can now really have a trusted channel, not just an encrypted channel, but a trusted encrypted channel between the client and the server. And finally, you have simplified management, which is basically saying, these certificates have an expiry date. So there is an end of life of these certificates, or you got to rotate them before this end of life. And so what we provide with our feature is a simplified interface that you can use to simplify this management and rotation of certificates with zero downtime. So we want to keep the cluster up 24/7, 365, and that aspect to do this with zero downtime is highly essential for us. So what you see in this figure is basically you have two clusters. You have a cluster A and a cluster B, and you can see the certificate at play in different aspects between these two clusters of how they interact. So first of all is the client to server. So when you see the client to server, you see that certificate is used, or that chain of the certificate is used as a part of the client server interaction. Secondly, you'll also see the certificate getting used between two clusters as an XDCR when you set up secured XDCR between these two clusters. They are the same certificate, which it is the same certificate on the server, but you only use the public keys on the client. Yeah. We will briefly also go through a demo of this, so you'll see some of this in action right later. So very quickly, how does this all work? I'm just going to walk through the mechanics of this. Typically, you would generate these private and public keys through a certificate generation tool. OpenSSL has its own set of tools that you can use for cert gen. You take these certificates. The way you configure the client and the server is you take the private key. This is a key for the server. You install it on the server. You take the public key. The public key is pretty much signed by the CA authority, which you bring. It is the CA, it's not something, you can tie it with your own CA authority, whether internal or external. You sign that public key, create this server certificate, which is in the public form, and also install it on the server. Now, as a part of the client-server negotiation, what will happen is the client will send the hello command to the server responds with the server certificate that you see here, and then the client walks up the chain to verify the certificate that, yes, indeed, does it belong to the same CA that it kind of trusts as well. And that's how the trust of the chain is verified. And finally, when the chain of trust is verified, you start the encrypted message between the client and the server. So that's a little bit of the details of how it works. We'll now switch gears into our next control, which is administrator auditing in Couchbase. So again, what is administrator auditing? So again, it is a feature that tells you for your administrators who does what, when, and how. Why is this important? Again, two things. Regulatory compliance, you've seen this coming over and over and over again. Finally, there is also understanding privileged activity. So within your cluster, you got to know, you might want to know what your administrator is doing. What are the kind of privileged operations that administrator is carrying out in the cluster? And that's exactly what administrator auditing is going to give you. How does it all work? Again, 3 tenets of the feature. You basically have configurable auditing. We have the feature that is you're able to set up auditing in Couchbase. You can set up a time period where these audit records can get rotated periodically. Then we also, the audit targets that we generate of Couchbase are in JSON format, which gives you this rich auditing capability. We have over 25 plus admin events which are audited. Again, highly rich, and you'll see some of them in the demo. And given that they are in JSON format, they're also easily integratable with your SIEM analysis tools, whether it be a Splunk or an HP ArcSight, any kind of tool. You might not see even some tools in this slide, but any tool which kind of can take these JSON records and kind of understand them and maybe visualize them, those tools can be really used for this kind of integration. So now we're going to talk a little bit on the futuristic stuff. We'll talk about 4.6, right? So you might have heard about our new release, 4.6. It's currently in beta. It's currently available on the website. So what is new in security in this new release? So the first feature that we worked on for 4.6 is what we call as secret management. So first of all, what is secret management? See, secret management provides encryption of system secrets using what we call as our own key hierarchy within Couchbase. And so this feature has 2 benefits. So first of all, it's regulatory compliance. You can see clearly that PCI dictates that they need cryptographic keys to be stored in a secure format, a secure way. And finally, we have simplified management. Whenever there's a key, you may want to rotate that key. And then you want to provide this ability to, again, rotate these keys with 0 downtime. The idea here is very simple. We have a system that is driven through a master password with this release. You take this master password, you use this master password, and you crack open what we call as a data password, and then that data password is then used to encrypt system secrets, right? So you have this hierarchy that you kind of see here, which is driven by the master password that you provide to the system. It's 0 knowledge. The system doesn't know this master password. The human operator who's operating the cluster has an ability to provide this password or provide it through some automated mechanism. Right? So that's a little bit on secret management. The next feature is pluggable authentication modules or PAM support. So first of all, what is PAM support? So Linux has this feature called PAM, and PAM gives you the ability to tie your authentication with a bunch of different services, whether it be an LDAP, whether it be local user accounts, and so forth. In this release of 4.6, we are focused on delivering PAM support for local Unix admins. So basically, you can have a local Unix account in your local machine. You can use PAM and then use this PAM module to basically authenticate based on your passwords which are on the local machine. So that's the power of this feature. Again, it gives you centralized management. If you already have a cluster where you believe in your Unix users, you really want to use Unix users throughout your setup, you may want to use PAM. And finally, security policy enforcement, right? With Unix users, you can do some strong security policy enforcements. You can have your own policies regarding password lengths, rotation times, all that great stuff that you can then use this feature for and get benefits just because it comes through your Unix operating system. So that's a little bit of the controls within the database. Now let's quickly go and look at the controls outside the database layer. So if you remember the architecture diagram, I talked about users, infrastructure, all those different aspects. So the first thing we'll touch upon is users. So first of all, what are some of the things you may want to think about outside the Couchbase infrastructure when you think about user security? The first thing is, as I mentioned earlier a little bit, is access management, right? So access management requires you to take these users and get them provisioned within your LDAP or PAM, whether it be local users or within your LDAP server. That's a manual or automated thing that is done outside the Couchbase system. So you have to go and configure your LDAP server to have these users in place so that you can use them within Couchbase. The second thing is also you can consider is you can use Bastion host to make sure that only certain users can log into your cluster. In that way you can isolate your clusters through an interface that requires your users to come in and log in via the Bastion host. And finally, you can also ACL. On your system, you can ACL what a particular user has access to. Maybe it be a configuration file, a particular utility, whatever it may be. Those are some of the things, based on your access requirements, those are some of the things you may want to consider for your users. Finally, we also talked briefly about auditing and in the previous about database auditing, especially in terms of administrators. And the second bullet here talks about OS auditing. In addition to your auditing control within the database, you may also want to audit OS activity, just the fact that somebody has done an OS login and then connected to Couchbase, so you can see and correlate these audit records. So that's why another thing to consider here is OS auditing, which you can set up based, most of the OSs have some flavor of OS auditing that you can use to make this, to track this user activity on the operating system. So the next thing is infrastructure security. So infrastructure security, a couple of things really quick here. So the first one is server protection. So what that comprises of is patches, regularly patching your operating system, antivirus, malware software installation, application whitelisting to make sure only certain applications are allowed. That's pretty much on the server side. Then there is the network protection, things like the host firewall and firewall rules that you might want to consider. On-disk encryption, what you have to do to encrypt your data on disk. And finally, if you're running on the cloud, then you have things respectively for the cloud controls, like private IP addresses, security groups, network ACLs. So those are some of the considerations or stuff that you have to think about in these three areas, outside, especially around the infrastructure realm. So we'll touch upon one of this aspect, right? I know there was a lot of stuff in the previous slide, but one of the things that we'll touch upon very quickly is on-disk encryption. So we talked about that's an external control, and what does it and how does it work at a high level. So with Couchbase, we do work with a bunch of strategic partners. You can see the strategic partners mentioned below. What this technology that they bring to the table provides is it provides you with a transparent and simplified on-disk encryption. It's an agent-based solution. It's a policy-based solution. You deploy agents on each of your Couchbase nodes, and these agents talk to a DSM or an HSM to kind of get the encryption keys and then do the actual encryption on disk. So the real attack vector that is solved by on-disk encryption is somebody really ripping your disk drive and running away, and in that case your disk is pretty much encrypted because of on-disk encryption. And finally, also, if there's a breach, if there's a single switch, you can just pull out your HSM or DSM plug, and pretty much you can't decrypt that data or get to it. So that's pretty much the high level idea for the on-disk encryption piece here. So the another interesting aspect is application security. So this comes quite a lot as we talk to a lot of customers, right? So a couple of things you might want to consider here, right? So things like access management and identity around wallets and application passwords. So when you connect to Couchbase, you need an application password. What we see with systems, whether you use a Java or .NET, is you have client-side wallets where you can store these passwords, manage these passwords, because that's clearly outside, at least from an application perspective, it's an application scope, and it's outside the database, what the database can control. The second thing is encryption, right? So we do provide strong challenge response protocols. In the past release, we have looked at SHA-SCRAM as a new protocol that we have introduced, within the product, which is still, getting there. And finally, we also have auditing and development best practices. So things around auditing briefly are data auditing that you may have to do outside your Couchbase in the application tier, and development best practices if you're using Nickel, things that you may want to consider when you're developing your application with Nickel. So we'll touch upon two of these very quickly in the next slides. The first one is application encryption. The idea here is where you will, in your application, use an SDK to talk to, let's say, an encryption service. In this case, I'm talking about Warmetric here, but you can choose your own encryption service. All of them provide this application encryption capability, and you can take that key, which is, as you see here, it's a social security number. As it goes through your application, you encrypt that piece of data and then store that encrypted field inside Couchbase. Things to mention about Nickel, again, some of the things while you're coding a Nickel app is you can see in the second line there is, instead of concatenating strings and not validating user inputs, you may want to use like something like the string builder or query request, and then just add these positional parameters so that it's much more safe when you're constructing this Nickel query. And those are some of the things that the .NET SDK provides, and similarly similar constructs are available in other languages as well, right? You also may consider using strongly typed constructs like Java POCOs and .NET POCOs and Java POJOs also provide this kind of capability. And there's an excellent blog that we had as contributed to us. So please check that out. It kind of goes over all the details and much more detail of how you can think about building these secure applications from an application tier. Okay, so we now have reached the most interesting part, which is the security roadmap. So the slide here I'd like to cover quickly is basically our roadmap at a glance. So some of the things that we are working on the short term. I'll start with that. So we talked about 4.6 currently being in beta. So our focus is on delivering, as we say, secret management and PAM authentication in that release. So you can see some flavor of it in the beta. On the medium term, which is our code name, what we call as POC, is we are working on a feature called role-based access control for applications. And what that is basically a feature that will give you the ability to control your application users and say who can do a read and who can do a write, and how do you separate a read from a write for application users. So that's something that is coming in this role-based access control feature. And on the long term, we also have a bunch of wish list items, right? So we have application auditing, Kerberos, native on-disk encryption, and the list goes on, right? I mean, I'm just talking about the more prominent items here. And again, this list is not ordered, at least on the long term. So based on your feedback, and your input, we'd like to work with you and help prioritize that long-term list. So finally, where are we all headed, right? So as I said, one thing you might have caught from my presentation, if not everything, was the word compliance. It came over and over again. In all the benefits of all the features, you saw the word regulatory compliance coming over and over again. And so compliance is an important aspect, right? So as businesses are adopting Couchbase, for Couchbase to meet compliance standards is also important. So that's our goal. That's where we are headed. We want to build the controls that will enable you to meet compliance standards. And here you can see an example of a compliance standard like PCI, right? So I'll very quickly go over this before I pass it on to Rhythm. The 12 controls of PCI. So you can see that those are listed here. Those are the 12 requirements of PCI. and how they translate to what we provide in Couchbase, right? So we'll go over them very quickly. So some of them are clearly outside, as I said, outside the database. The first one being install the firewall, install a firewall. So we briefly touched upon, hey, Couchbase needs to be installed in a firewall infrastructure. Similarly, there are others in this list, right? So the last one, maintain a policy that addresses InfoSec for all personnel. So that's clearly, your organization requirements for managing, security. So the more important ones, at least, which are currently getting worked on, you can see the second one here. The key management piece is an important thing that will fill that gap and improve some of that work. There are also the yellow ones. Maybe we should focus on the yellow ones. So the yellow ones talk about some of the stuff that we saw in the roadmap. The first one being role-based access control for applications. So we already delivered role-based access control for admins. That's something we talked about. But role-based access control for applications is something that's coming in our roadmap. Similarly, you'll see the PAM support in the future. As I said, the future list does have some of these other authentication improvements, two-factor auth, single sign-on, which are on the future wish list. And the another important aspect is tracking and monitoring admin access. So there we have admin auditing, which was already delivered, and application auditing is something that we are, as I said in the roadmap, is something that we are going to look at. So again, I'm going to show again the roadmap for folks who can, so we can connect the dots here. Is basically Spock, RBAC for applications, something that we are working on post 4.6, and finally a bunch of wish list items, which we need to prioritize along with your input. So that's it. So I'd like to now pass it on to Rhythm for the exciting demo.
Right, thanks, Don. So what I'll do is I'm going to demonstrate out. We'll go in order of the role-based access system. I'm going to show you out what is an auditing look like, and we also look at this X509 certificates. For X509 certificates, I've already set up the root certificate and the key certificates up. We're just going to show how the uploads are going on. So at this point of time, what I have is a 3-node set. It's a 3-node cluster. Let me refresh and back. I have a 3-node cluster, and it has 2 data buckets. One is default and one is travel sample. And also set up out with my LDAP. I have a few users called Don, Igor, Rhythm, Tony, and Wayne already created in my LDAP system. What I'll go back and do here is let's take a hypothetical example of where you have an organization and you do not, you want to control the levels of administration within them. We'll take, for example, we have a user called Wayne. So let me go back and enable authentication. So this is how you go back to the security tab, go back, authentication, enable them. And I'm going to add a user called Wayne. Wayne is going to be a system administrator at this point of time. Let me go back and choose admin. All right. At this point of time, an admin is equivalent to an administrator system. Post 4.5, we did support out LDAP, but then we only had administrator user in there. So that was the default role that is available. But with 4.5 with RBAC coming in, your first role can be an admin. An admin will be a super user equivalent to an admin. I'm going to add another user called a cluster admin called Tony. Cluster admin is kind of one level down the super administrator. Cluster admin can do everything, can add nodes, create buckets, create views, etc. in the system. But the only thing that he does not have access to is the security. So you can have one guy who is kind of a system administrator who controls the entire security and everything. But then you have a kind of a support manager who takes care of other things around this, or an IT administrator who takes care of everything, but he cannot work on the security part. I'm going to add the third user called Igor. The weird thing that you see here is if you see bucket admin has 3 things. If you see bucket admin star, as I said, I have 2 buckets in it. You have bucket admin default, and you have bucket admin for travel sample. The reason that we wanted to do with bucket admin is have a user very specific limitation to only bucket. So let's take an example. You have one bucket, let's assume it has financial data. There's another bucket that has IT administrator data, and you have a third bucket that takes care of any coordination data that you have internal. And you want to make sure that when you have a user in the system only has access to one particular bucket, not any other particular bucket. So in that case, when you go back and create a bucket admin, you can define a user to a particular bucket. For example, if I want to give Igor access to only default bucket, I give him out access to default bucket. And when he logs into the system, he can only see default bucket. He'll not be able to any other buckets like the sample bucket or any other bucket that exists in the system. So this way, he is only able to manipulate the bucket statistics or bucket settings, as well as the bucket data that is in there. So for right now, for simplicity purpose, I'm just going to give him everybody a bucket star, so that we can do some more operations. Similarly, the next one comes here is our views admin. With views admin, let me add so I can show you much more clear. So I'm going to add return and views. So again, with views admin, we have the same concept. The reason for doing out bucket-wise in case of views here is, if a user wants to create out a views, then again the views are very tightly coupled out with the bucket. And then we also want to show him the data for a bucket, but has to be read-only. So this user practically practically can create out views, but the data is only read-only. We'll see that in the demo when I log in with each of these users coming in. So for simplicity purpose, I'm going to give out views admin. And the last one, I'm going to go back and say we have the replication admin, that is the XDCR admin. This admin can only create remote clusters and can create replications in the system. All right, so that's why let me log out of the system at this point of time and log in as Wayne. As I said, Wayne is a super administrator in the system, the equivalent to the administrator that we have. In terms of server nodes, you should be able to add servers, remove servers, fail them over, create out a bucket. Let's create out a bucket if you want to say. Let's give it a second for it to warm up. All right. He can go back, create out views if he wants to, XDCR. And note that this guy is an administrator, has access to the security tab, can add, remove users as it wants to. What we'll do is just to make sure that I'm going to enable auditing here, because that's what we also want to see in the next term. So he goes back, enables auditing out here. And we have the bucket also created out here. I'm going to sign out of Wayne at this point of time, come back to Tony. Tony is a cluster admin. So the difference between a system administrator or the administrator versus the cluster admin here is on the top, you don't see any of the roles that is for security. So the security tab is completely hidden for him. He cannot act on any of the security tabs. But yes, he can go back, add servers, remove servers from them, make them failover, create out data buckets, indexes, XDCR, and as well as settings. So I'll just go back and update one of the settings so that we know that he has access to the settings tab. And let me go back and create a bucket here as well for him, so it becomes an easy cluster. Let's make it 100, and let me create the spelling mistake here. Right, so this way we created out a bucket, and he's able to see everything except the security tab. Now I log back again. I log back as a bucket admin, Igor. Now with Igor, what happens here is one level down, the cluster admin, he has only access to the buckets and what is relevant to the buckets itself. There's no security tab for him. The settings tab is there for him, but it's only for view-only mode. And the server tab, he can see what servers are there, what is the RAM usage, swap balance, etc. for it, but he cannot act on it. But when it comes to bucket, note that there is no create bucket for him. He cannot go back and create a bucket, but definitely he can go back and administrate a bucket. He can go back and say, edit a bucket. And let's say I just want to change the settings. I just want to increase the memory out here. He should be able to do that out. Plus, if you look at the documents part, he should be able to create out a document, edit a document. That's all the buttons are available out here. And he should be able to go back and work on the views as well. I will just create out a development view saying, so that's something that is something a bucket admin can do. I'll log out of the system again. I'll log in back as Rhythm. Rhythm is basically a view admin. The difference between a bucket admin and view admin here is that everything is read-only for him in the system. He does not have access to the security tab. He can look at all the buckets out there. As I said, a view guy cannot create a view without looking at the data that's there in the system. So basically, he has access to the documents tab, but the documents are only view admin for him. He cannot go back, create any documents in the system at this point of time. Of course, he can go back and look at what the document looks like, so that he can go back and construct a view in the system. What I'll also demonstrate here is, let's go back, create a view. I should be able to create out any development view via View Manager. The last one is a user called, we created Dawn. Dawn is the replication admin. In case of Dawn, he has access to the server nodes. He can see the data buckets. He can see the documents as well, but only the view documents part. We have the indexes, but he cannot go back and create any of the views in the system. Logs you can see. Settings are only read-only. The main purpose here is XDCR. He can go back and create a remote reference here. Right, so he can go back and create, that's the only thing that he can do in the system at this point of time. Go back, create a cluster reference and a replication. So I'll just pick up default, and let's pick up the remote cluster. And I'll just start a simple replication out here. So that's what a replication admin can do in the system. So this is how the role-based access, as Don showed, right? We have the big picture, and then we have other roles as part of not union, but it's kind of a intersection between the roles as we go through the level of hierarchy that is there in the system. The second thing that I wanted to show out is about auditing. Since we have enabled auditing in the system, I should be able to show you out the logs as well. So when you enable auditing, there is an audit.log that gets created in the system, which basically puts in a record for every audit, every action that is taken in case of the admin. It can be either through the UI or you can use the CLI, doesn't matter. But whatever an administrator, anything that as an admin part to it gets administered here. That's what I'll do here is I have a copy pasted a little bit here, just wanted to show out a couple of things. So audit is mainly useful for a company to know what's going on, who has done what at what time and from where. So few things that you need to look out here is each of these audit records have a real user ID and has a source and the username attached to it. So in this case, Igor, let's just take an example that Igor logged into the system, right? And what kind of user he is can be SSL authority. If it's a plain administrator, it would be kind of an internal user to us. So the user type would become an internal and the user would be administrator. Each of these will have an attached with a session ID. Just in case in future you want to go back, run some analysis on what happened for a particular session and what exactly a particular user did for a particular session, you can go back and use the session ID as part of your search parameter. It also captures the IP address from where the request originated. So it's just like a use case where somebody's outside the system or where exactly is in the system is something that you would know. The other part here is important part here is the timestamp. What happened when this is all UTC full timestamp. So you know what the time this thing happened. Apart from that, you have the ID, you have the name of the the bucket or the audit event. You have the audit ID, the audit event, and the description. I'll just quickly run to show you down how. Let me do one thing here. Just gonna go back and delete this. So one of the things that we do is, example, somebody comes in and changes bucket statistics. So it just prints out the list of properties that were changed for that particular bucket. as part of the bucket description. So when assuming that Igor came in and said, I want to change the RAM of the bucket, or I want to go back enable it for flush, or I want to go back increase, I want to have more views admin in the system. That's where we'd go back and put in the exact property that change in for the bucket. The bucket name is also present there, as I said, the regional user ID, who did that, the session ID, the remote IP address, the timestamp. There's a particular ID attached to that particular event. There's a name attached to that particular event, and there is a bucket description attached to a particular event. So that's in a nutshell that we have for auditing. I'll quickly walk through.
Question about auditing?
Yeah.
Are you doing syslog? Or are you logging locally to disk?
This is logging to the disk, right?
Any plans on supporting syslog?
I can take that. Yeah, so syslog is not like it's definitely on our roadmap. That's an enhancement to some of the auditing work we are considering. Again, as you saw on the roadmap, that's it. The bucket that it will probably be is in that futuristic long-term roadmap bucket. Again, that's great input. We like to listen, to more input like that, so that we can, prioritize some of these enhancements to some of the features you're seeing. Yeah.
Very quickly, I'll walk through the SSL part of it. So this is, by default, if you know, the Couchbase comes with its own self-signed certificates. If you go back, look at the view certificate, it's signed by Couchbase server for this particular IP address. That's how it works out. And your root certificate is available here. Go to security, and you can get this root certificate from here. What I'll do is I'll just run a simple command of I'm going to go back, upload my CAPM from here. So that's the certificate, my root certificate, that is the public key that gets uploaded in the system. And then we have two other steps where we're going to go back and we do reload two things. We reload up the node key. You need to have a node certificate as well, right? And if you're using an intermediate certificate, you need to have a chain key that has the intermediate certificate and the node certificate as well to create the node key part of it. So I'm going to quickly do that. Let me do it. And if I simply go back and I'll do a refresh, it should be taken out. If you look at it, my self-signed certificate now has a subject. It has changed back to my root certificate at this point of time, or whatever I uploaded in the system, which is generated by my OpenSSL. If you have a local CA, you can go back and generate it from there. And what I'll do is I'm just going to go back, show a small demo out, and how this one configures out with my. I have a small program that's written out that runs it just goes back and inserts a few keys. So basically what happens, what I want to demonstrate here is we have reloaded a certificate at this point of time. And right now we've moved away from using a self-signed certificate that came in from Couchbase to a certificate that is generated by our certificate authority. This command tells you that we are running an S, which the Couchbase S means it's an HTTPS. And the third part is the root.crt that I copied from the public key from Couchbase itself. And let me go back to the data buckets. And my default sample now is, I've put it 1 second, but we now have ops coming into my default bucket. So that's in a pretty much quick nutshell that I have in terms of both RBAC, auditing, and as well as X509. Don, do you want to take it? Thanks, Don.
Okay. Okay, thanks, Ritam. I hope you guys enjoyed the couple of demos that we showed you today. So that brings us close to the end of the presentation. So I'd like to thank you guys for coming here. But I want to, given that we do have couple of more minutes, I think we should just do a bunch of Q&A. So there's a couple of questions, which I told you guys we can ask at the end. Now is the time. Okay, go ahead.
Regarding the certificates, those were self-signed certificates. Can we put the other certificates also, like the organizational approved certificates?
Yeah, so the idea there is where you can bring your own certificate authority. So we don't control, how, which authority signs your certificates. We work with customers who say, hey, we have their own internal CA, where they say, okay, they have tools, to generate certificates from their own internal CA. So you could, generate those certificates and load them. There are also others who say, hey, we trust VeriSign, or we trust, although they are expensive, so they to generate those certificates, right? A VeriSign certificate could be expensive, right? So, but there are still folks who do so. So we have no control. We basically say, bring your own certificate authority, whatever certificates you give us, as long as they are in the PEM X509 PEM format, we can load them into Couchbase. Yeah. I believe there was a question there, and then I'll go there. Yeah.
You audit changes, so you'll say, Bob changed the size from 100 to 125 gigabytes. You actually say the new value is 125, but you don't say what the old value is. That's very difficult to go back and change through and find out what the original value was if you need to go repair something. Can you do old and new values when you do auditing?
Correct. Yeah. So that's right now no. That's again a good point and good feedback. So we initially, when we designed this feature, we thought it would be great. We want to also differentiate a little bit between audit logs versus general logs. Because we don't want folks to use these, especially audit.log file, to go and do system logging, because we believe that's a different use case versus our use case is generally around security, right? But again, that's a valuable feedback, so we'll also track that and keep it in our roadmap. Yeah. Yes.
So regarding roles, can you have mixed roles or combination of roles? You only want to read access to financial data, the admin privileges, to have bucket.
Correct. Yeah. So a little bit on the role. So the question was, do you allow the capability for mixed roles where you can have admins doing some things versus you can have access to financial data, read and write access, if I understood that, for financial data. So that's a mixture of two features, right? So it's a mixture of admin role RBAC as well as data RBAC. So admin RBAC, as you saw today, you could have a user, let's say Don, and that user could be a bucket admin as well as an XDCR admin. So although those roles are kind of canned roles at this point, you can't change the privileges in the roles, but you can give a user one or more role. And the effective permission then becomes a union of these both roles. Now, we also have a feature in the roadmap which I showed you is basically the idea for application RBAC. So with application RBAC, you really will be able to do, allow Don to have, let's say, read access to just this bucket or write access to some other bucket, right? And a combination of application RBAC as well as admin RBAC will give you a huge set of capabilities to control access within your system. Yeah. Yeah. Yeah, so I'll go back there. So the plan, again, all of this is a plan. The idea is to work on this in the medium term and around 8 to 12 months from now on, right? So actually it's 8. Let me correct myself. It's 8 to 12 months after 4.6 ships. Yeah.
Tell me another question.
Yes.
On this encryption, are we supposed to take care especially for query indexing part of it? Because if we are going to encrypt the data and store it into the databases, is our query analyzer going to change its behavior where we have to inject more security features?
Okay, so the question was, with on-disk encryption, does it impact my query engine or indexing engine on any of that? So, the on-disk encryption is basically a transparent solution in Couchbase. You can think of it as a layer just above the disk. So any reads and writes flow through this layer, get encrypted down. When it gets up, it gets decrypted. So it's kind of transparent to the query engine. So the query engine doesn't see this. The key highlight in that feature is basically if the real attack vector is somebody ripping out your disk drive and running away. So it's not going to impact any of the changes about. I think we've been called to wrap up. So if there are any questions, we'll be around. So please feel free to grab us. But again, thank you all for coming here.
Thank you.